Hello students, once again welcome you to GK's maths classes. Today we are going to start a new chapter called differentiation. Already we have done continuity and differentiability, and today we are going to start with differentiation. This is actually a continuation of what you have done in class 11, where you have done basic formulas and differentiation, and then you also did the chain rule, you also did a product rule and quotient rule. So we will not be touching on those things. We will straight away start with chain rule. But before we go into it, just a quick introduction of what differentiation is. Okay, now what is differentiation actually? Suppose if you have a function, say y equal to f of x is a function, y equal to f of x is a function. It has two variables. What are the two variables? The two variables are x and y. X is an independent variable, and I assume y is a dependent variable. Okay, but you also know every function graphically represents a curve. Okay, every function graphically represents a curve. So let's draw a random curve. This is a curve y equal to f of x. For example, I have y equal to f of x. Okay, now what I do, I choose a point A. Okay, I choose a point A where at this point I want to draw a tangent. Okay, at this point I want to draw a tangent. So let me draw a tangent there. I want to draw a tangent. This is my tangent. Slight adjustment. So I have drawn the tangent. This is a tangent to the curve at x is equal to a. Okay. Now what I do, I take two neighboring points. The one point is, say, for example, I'll take it as B, and I'll take another point, say C. Point is C. I'll mark it with blue color. Also point C. Okay. Now what do? You draw a secant connecting these two. Let me make a copy of this. This is the secant. Correct? This is a secant. So for example, if this is say this point is say x comma f of x, this will be since it's little less, it is x minus c comma f of x minus, or you can say x minus h by f of x minus h, where h is positive. So what is slope of AB? So slope of the secant AB will be y2 minus y1. What is y2 minus y1? y2 minus y1 divided by x2 minus x1. All this you have done in class 11th. Correct? So I get the slope of my secant as f of x minus h minus f of x divided by h. Now what I do, I allow B to approach to A. So B is coming to A along the curve. When B approaches A, clearly x minus h approaches to x. Correct? That means x gets cancelled, so h will approach to 0. So this is my left-hand derivative. So left-hand derivative at A. What is that? Limit h approaches to 0, f of x minus h minus f of x divided by minus h, it's actually minus h, and its value is nothing but f dash of x at x is equal to a. So when you allow B to approach to A, this secant will slowly become a tangent. the secant slowly approaches and becomes a tangent. Same thing happens for this point C. Now you can look at this point C. See, for example, what is slope of AC? y2 minus, this is what point? This is x plus h, comma f of x plus h. So slope of secant will be f of x plus h minus f of x, y2 minus y1 by x2 minus x1. So they get cancelled. I get f of x plus h minus f of x divided by h. This is slope of my secant AC. Now if I allow C to approach to B, when I allow C to approach to B, then I will get my h to become 0. So it will be f of x plus h minus f of x divided by h, which is nothing but f dash of x at x is equal to a. And we have learned that if left hand derivative is equal to right hand derivative, difference derivative exists, and you also know that dy by dx always acts along the tangent. I will give you the proof for that. Okay, so if I extend this, I will just show you in GeoGebra also. Okay, it's always good to understand the graph. You see, now here I have taken a function. Okay, see this. I have taken a function y equal to x cube plus 3x square, which represents the curve, which is represented by the green color. Okay. Now what I will do, I will choose an arbitrary point. Okay, just a second. Let me move this a bit. Okay, now I have chosen a point B. Okay, I am going to move this point B. Look at the slope of AB. This is slope of AB. Slope of AB is 4.7. So when I move B, my slope changes. Correct? My slope changes. And see what happens when I come to this point A. When I reach this point A, you can see the pink, that's a tangent. The secant becomes a tangent. I'll just show you once again. See this? This is a secant. Can you see this is a secant? And this is the tangent. Slope of the tangent is -3. Okay. Now, when I move this, the secant slowly becomes a tangent. And you can see clearly my slope is actually, let me see this. Just a second. Okay. Now look at this. Once again, I'll just show you. When I move this, look at this. This is my secant, slope of the secant AB, which is 2.37. So when I slowly move this and approach to B, okay, when it approaches to B, slope of the secant approaches to slope of the tangent. So left hand derivative is f of 3. Similarly, what I do, look at this point C. I move this point C. See what happens to the slope of the secant? Slope of the secant slowly changes. When I reach the point B, I reach the point A, slope of the secant becomes equal to slope of the tangent. So whether I approach to the left side or I approach from the right hand side, my LHD and RHD are equal. Therefore, the function is differentiable. And you can see clearly my derivative is nothing but slope of the tangent. Now, if you want to verify it, you can always do it. Now, what is dy by dx? Dy by dx is 3x square plus 6x. 3x square plus 6x. And I want to find the slope of the tangent where at x is equal to, I think the point should have been, I think it's difficult to verify with this type of a point. So forget it. If you substitute any point, say x is equal to, I don't know what this point is, so that becomes very difficult to calculate. Okay. Okay, that's fine, no problem. So we have verified it. that slope of the secant approaches slope of the tangent. So what is the geometric meaning of dy by dx? The geometric meaning of dy by dx gives you slope of the tangent to the curve. Okay. Now with that, we will continue with our usual routine of solving problems. This is what I was talking about. So I have taken a point B, I have taken a point C. B approaches to A from the left side, C approaches A from the right side. Both of them approach to a particular point, and that point is nothing but, at that point, the slope of the tangent is f dash of C. Now, there are various formulas that you have learnt in class 11th. I have displayed the formulas for your reference. You can always look at it. There are totally, I have 17 such formulas, and I have written product rule of UV, UV dash plus VU dash. I have given you product rule of UVW also, which is UVW dash plus UV dash W plus U dash VW, and I have given you quotient rule also. Okay. I hope this is clear. I mean, you can always go through the formulas. The third formulas, you can't touch these problems. Now, what is that we are going to do in differentiation? We have a lot of subtopics in this. The first thing I'm going to introduce you is the basic, that is chain rule. Then I'm going to talk to you about differentiation of inverse trigonometric function, followed by differentiation of implicit function, then differentiation of logarithmic function, differentiation of parametric function, differentiation of a function with respect to another function, and finally higher order derivative. So it's a huge chunk of problems that we may do, maybe around 50 to 60 problems we may do. So I hope we will not be doing in one video. So today I will try to cover chain rule. So maybe 1 or 2 videos per subtopic. I think that we should be able to cover it. Okay. Now let's go into chain rule straight away. Now what is chain rule? The chain rule is basically about composition of function. Okay. Instead of understanding as a chain rule, what I say is, suppose I want to differentiate a function like sine cube, say log x. I want to differentiate a function like sine cube log x. Okay, how do I look at it? I always start from the outermost term. What is the outermost term? It is 3. So first I will differentiate the power. Okay, I also use this word called power, base, angle. Okay, there are different techniques, but ultimately you should learn how to differentiate. So power. So just look at this as x power n. So what is x power n? It is n into x to the power of n minus 1 log x. So x power n into x to the power of n minus 1 log x. After the power, go to the base. For me, the base here is sine. Differentiation of sine is cos log x. Once you have done with power, don't take the power along with you. So differentiation of sine is cos. It's a chain rule, so it's multiplication. Derivations are there, but we will not go into all that. Now after that, go to angle. What is my angle? Angle is log x. Differentiation of log x is 1 by x. So this is complete differentiation of sine cube log x. Okay. So let's do one by one the problems. Now look at this question. First of all, what do? You call this as y equal to ax square plus bx plus c, the whole power 1 by 2. So first I want to differentiate my power. Okay, always the power first. So dy by dx, that is the outermost term. Dy by dx will be n into x. This entire term acts like x for me. N into x to the power of n minus 1. N into x to the power of n minus 1. Done? So I am done with the power. Now into, go to the base. Go and differentiate ax square. Differentiation of ax square is, a is a constant which remains as it is. Differentiation of x square will be 2x. Okay? Plus bx. B is a constant along with the coefficient, which is a coefficient of x, and differentiation of x is 1 and differentiation of c is 0. So this is complete differentiation. If you want, you can simplify this as 1 by 2 You know half minus 1 is minus half. You can bring it down. Ax square plus bx plus c into 2ax plus b. This is the complete differentiation of this. So first you differentiate the power, then you differentiate the base. And differentiation is done only on the numerator. Now what do I mean by that? Look at this problem. This is in the denominator. So you can't go to the denominator and differentiate. So what do? You pull this up. Minus 3x square plus 4 whole power minus 1 by 5. Okay, whole power minus 1 by 5. Now I am going to differentiate dy by dx. So what do I see first? For me, I see the power. What is my power? N into x. What is my x? This entire term is my x. N into x to the power of n minus 1. N into x to the power of n minus 1 into, I have done with the power. Now go to the base. What is differentiation of 2x cube? 2 will remain as it is. X cube differentiation is 3x square. So it will become 6x square. Correct? Minus, because there's a minus sign, 3 will remain as it is because it is with the coefficient of x. And x square differentiation is 2x. So it will become 6x. And differentiation of 4, it is standing alone as a constant. So differentiation of constant is 0. That's it. So the answer can be written as 1 by 5 into 2x cube minus 3x square plus 4 the whole power 6 by 5. If you want to keep it as minus 6 by 5, no issue. Otherwise you can write it as 1 by 6 by 5. And here, if you want, you can simplify. 6 is common, or you can just write as it is 6x square minus 6x. This is the differentiation of that term. Am I clear about it? Now come back to this. I am done with the algebraic functions. Okay, these are 2 algebraic functions again. Now I am going to involve trigonometry. So here I will write y equal to sine cube 2x square plus x plus 1. So when I want to differentiate, that is dy by dx, first derivative or first order derivative, I differentiate the power. What is the power? 3 sine square, y sine square, n minus 1, 3 minus 1 into 2x square plus x plus 1. First I differentiate the power. I use the formula x power n. N into x to the power of n minus 1. 3 minus 1 is 2. Into, it's a chain rule, into. I am done with the power. Now what I should differentiate? I should differentiate sine, the base sine. Differentiation of sine is cos of 2x square plus x plus 1 into, not done, go inside. I am done with the power outermost. Then I go inside, that is sine. Now I keep moving inside. What is that? 4x plus 1, because differentiation of x is 1 and differentiation of 1 is 0. So you can close it. So this is complete differentiation of this term. Power, base, angle. Done. Okay. Now how do I differentiate this? Suppose I have got y equal to square root of tan of square root of 2x cube minus 1. So what is the outermost thing that we see? The outermost term that I see is the root. So how do I differentiate root? How do I differentiate x power half? Half x power half minus 1, which is half x power minus half, which can be looked at as 1 by 2 root x, class 11th. Simple. I am applying the same logic here. Dy by dx is, First I differentiate the power. Root of this, which is 1 by 2 root of this entire thing. So I have done with the root. After the root, what do you see next? I see tan. What is differentiation of tan? Into tan differentiation is secant square root of 2x cube minus 1. After differentiating tan, what is the next term that you see? After that, I see once again the root. So what is differentiation of this root? 1 by 2 root of 2x cube minus 1. After differentiating this root, what do I see? I see 2x cube, which is 6x square, because differentiation of x cube is 3x square. 3 into 2 is 6x square. And differentiation of 1 is 0. I'm not interested in simplifying this. We are only learning how to differentiate. So let us not bother about simplification. Is that clear? Power, then tan, then root, then 2x cube. See, you keep moving inside. Okay, that's what chain rule is all about. Let's come back to this. This is y equal to log cube sine of 3x power 4. So if I want to differentiate this, what do I differentiate first? Right, you have to differentiate the power 3. How do I do that? 3 log square sine of 3x power 4. So what did I do? I differentiated the power, that is 3. N into x to the power of 3 minus 1. 3 minus 1 is 2. Into, after dealing with this, what do I see? Next I see log. What is differentiation of log? Log x is 1 by x. So what is log of this? 1 by sine of 3x power 4. So I differentiated log. After differentiating log, what do I see? I see sine. What is the differentiation of sine? Cos of 3x power 4. After differentiating sine, what do I see? I see 3x power 4. How do I do that? It's 12x cube. Why? X power 4 differentiation is 4x cube. 3 into 4 is 12. So if you want, you can just slightly simplify this. Log square sine of 3x power 4. This is cot of 3x power 4 into, you can just say 36x cube. Simple differentiation. Let's do one more. Y equal to, you know, differentiation cannot be done in the denominator. So what do? I take this up, log of cos x, the whole power minus 1. Correct? If you go, take it up. Now dy by dx, what do you see first? I see the power minus log of cos x, the whole power minus 2. Why minus 2? N into x to the power of n minus 1. Minus 1 is minus 2 into, after dealing with minus 1, I have to see log. What is differentiation of log? Correct, 1 by cos x. After that, what do I see? Cos. What is the differentiation of cos? Minus sine x. Then what do I see? X. Differentiation of x is 1, no need to write. So minus into minus is plus. Sine by cos is tan. Log of, or you can write by log of cos x, the whole square. If you want, you can even use quotient rule. But since it is a constant, this is much easier to do. Okay? It's up to you. Now what's the next one? This is about exponential function. Y equal to e to the power of tan square x cube plus 1. You know differentiation of e power x is e power x. Correct? So when I differentiate e power anything, I first get all these things. There is no change at all. E power tan square x cube is e power tan square x cube. Done with e power. Into, now go to tan square. Now here what do you see first? I see 2 first. That is 2 tan x cube plus 1. How did I get this? It is 2 tan 2 minus 1. 2 minus 1 is 1, so I am not writing that. Into, after dealing with the power, I deal with tan. What is the differentiation of tan? Secant square x cube plus 1. After dealing with tan, what do I differentiate? X cube plus 1. What is the differentiation of x cube plus 1? 3x square. And differentiation of 1 is 0. So, if you want, you can simplify this. This is 6x square e to the power of tan square x cube plus 1 into tan x cube plus 1 into secant square x cube plus 1. Simple. First I differentiate e power, then normal differentiation. Let's come back to this simple question. This is y equal to e to the power of root of cos of root x. Now what happens? You know very well differentiation of e power anything is the same thing. Done. Into, what do I see now? I see the root. How do I differentiate the root? 1 by 2 root of cos of root x. Root x differentiation is 1 by 2 root x. So here in place of x I have cos root x. So I have dealt with root. After root, what do I see? Cos minus sine root x, because differentiation of cos is minus sine. After cos, again root. What is that? 1 by 2 root x. Then differentiation of x is 1. Okay, simple. Not much to simplify, so I'll leave it here. Now the last two problems. Y equal to, this is involving sine, inverse trigonometry. Sine inverse of root x. What do I see first? I see the root first. How do I differentiate this root? 1 by 2 root of sine inverse root x. First I deal with sine, root. Now sine inverse. What is sine inverse differentiation? Root of 1 minus x square. Sine inverse x differentiation is 1 by root of 1 minus x square. So in place of x, I have root x. What is that? Root of 1 minus root x the whole square. It's root x the whole square, which will be x. So I dealt with sine inverse. After sine inverse, what I should differentiate? Root. What is the differentiation of root? 1 by 2 root x. So if you want, you can write it as 1 by 4 root x into root of sine inverse root x into root of 1 minus x. So root, then sine inverse, then root. Let's do this problem. Y equal to tan inverse of x cube whole power 4. dy by dx is equal to, first is the power. What is the differentiation of the power? 4 tan inverse of x cube, the whole cube. Why whole cube? 4 minus 1 into, what is differentiation of tan inverse? Differentiation of tan inverse x is 1 by 1 plus x square. If it is x, it is x square. It is actually x cube. So it will be 1 by 1 plus x power 6. Why? X cube the whole square. Correct? And then after differentiating tan inverse, what do I differentiate? X cube, which is 3x square. So very simple. With that we finish chain rule. All that I want to tell you is, once again, I have done at different levels. You see, first I dealt with the problems involving algebraic functions. Then I went for trigonometry functions. Then I introduced you to logarithmic differentiation using chain rule. Then exponential function using chain rule. And finally, I have come to inverse trigonometry. I thought I'll just do one more problem just for a completion. 2 to the power of sine root x. Suppose I have a question. This is also exponential, but I have not dealt this formula. dy by dx will be, a power x differentiation is a power x log a. So 2 power anything will be 2 power sine root x into log 2, using that formula. Then differentiate sine. What is that? Cos root x. After sine, what I differentiate? Root x. 1 by 2 root x. This covers all types of problems that you can experience in chain rule, okay, that you will be facing when you do further more problems. I hope this video is useful to you. Kindly subscribe to my channel. Also click the bell icon to get notifications on all video. Next class we'll start with implicit function differentiation. I hope it's useful to you. Have a lovely day. See you. Bye-bye. Thank you.